impressive list of academic, scientific, scholarly merits. So I will just proceed to ask Professor Nordhaus of our university to take the floor.
I would like to join the others in welcoming Nick Stern and his team to Yale. This great hall is Yale's great concert hall, actually, and it reminds us that economics is an art as well as a science. The Stern Review has put forth a very somber assessment of the risks of climate change. I put one of the more striking quotations up here for you. It concludes that if we don't act, the overall costs and risks of climate change will be equivalent to losing at least 5 and as much as 20% of GDP or more. The review proposes sharp and immediate reductions in emissions. I think that was not sufficiently highlighted today. And although it uses the tools and language of economics, its results are dramatically different because of this call for immediate action. And what I want to ask is, what is the reasoning behind this radical revision? Is it based on sound economic analysis? And what should we conclude? Before I do this, I'm going to start with something a little different. I want to actually start as a survey the reviewers of the reviews. There have been at least a dozen very careful reviews of the Stern Review. And I thought what it might be useful to do is provide a summary of what I think the areas of agreement and disagreement or potential disagreement are. This is my own view, and I'm sure that other panelists will disagree with even this summary of agreements. But I think it would be useful to start with these. Now, there are 5 propositions that I think are areas of agreement among the Stern team and much other research in this area, economic and scientific research. The first and most important one, I think, is that global warming is the state-of-the-art science. It's good science, and I'll just show you one diagram I'll leave this up here a second, a very important diagram, the Keeling curve, and if you wonder where all this started, it probably started with this curve. The second item of agreement is that unchecked warming may lead to large and costly long-run ecological and economic impacts. And here there are lots of words in that. They're all important: unchecked, large, costly, long-run, ecological, and economic. A third one, which was emphasized in the presentations this morning, is that the complexities and uncertainties are enormous in this area. In the science, to begin with, and perhaps most importantly, I think what was not emphasized this morning was also the uncertainties in the ecological impacts, broadly speaking, and in the economics as well. Getting into the economic side of things, I think there's consensus among the researchers that global warming is a major, what's called a global public good, sort of everybody's business and therefore nobody's business in a sense. And the fifth one, which is that solutions will involve raising the market price of carbon. Now I want to pause a minute on this fifth point because it is a very important statement in the review and one that differs from some of the other discussions in this area. The review emphasizes the need for increasing the price of carbon emissions. It might come through a carbon tax, it might come through auctions or trades of marketable emission permits, such as are now being traded in the European Union. I just call these carbon taxes because it's a short word. But the point is it's really a shorthand for a market penalty or limitation. The important point which the review stresses, and economists as slightly unpleasant people to begin with always emphasize, is that a carbon tax, raising the cost of carbon, is necessary for a solution. It's necessary both to provide incentives to individual firms and to households to get them to curb their emissions, and something also that's probably just as important in the long run is to stimulate research and development on low-carbon technologies. Carbon prices have to be raised to transmit the social costs of this to the everyday decisions of billions of firms and people. Now, this inconvenient economic truth is virtually absent from most economic discussions of climate policy. And if you saw Al Gore's documentary, he gingerly walked up to this point, asked about the costs of climate change, and then he backed away by saying it was an opportunity and not a cost. But the review emphasizes it must be faced as a penalty for those who emit carbon. Now, the second two, there are some major or minor disagreements, and these are in the areas of the trajectories of emissions and temperature and impacts, and also the central estimates of climate damages and abatement costs. Now, what about the underlying description? Here, I think the critics are divided. Maybe the discussants are divided, I don't know. But some have been very critical, and some have said, well, it's a reasonable view of the world. My own personal reading is that, on the whole, it's a reasonable interpretation of the existing science. I think they do exaggerate some of the extreme events, and I think they compound some of the extreme events. And it's not clear to me exactly what, if you actually were to look behind these into the black box of the minds of the reviewers or of the page model, what exactly is going on. But the other side of this, I think this is extremely helpful, because we know that there is a tendency among humans and institutions to underestimate risks, and even more importantly, often to forget about correlated risks. But in any case, the differences here are probably in the tens of percents rather than the hundreds of percents. Now, in one respect, I would say the review inflicts cruel, unusual punishment on the English language. And in the quote I started with, it said that it finds the cost of climate change equivalent to a 20% cut in per capita consumption now and forever. And this frightening statement suggests that we're about to drive off a cliff. That just walk out here and all of a sudden that you will find yourself not in snow but in seawater. But actually, when the review says now, it doesn't mean today. And so it's a little confusing. In fact, these impacts are far in the future, and the calculations in the review, particularly this calculation, depends critically on the assumption of low goods and time discounting. And just to give you some numbers from the review, in that you take their mean loss case, it's 1% of world output in 2050 and 3% of world output in 2100. And this becomes 20% now. So again, you've gone somehow from 3% in 2100 to 20% now because of an extreme assumption about discounting, which I'm going to talk about in a little bit. I think this is actually an exaggeration of about 2,000%. But the result is actually not primarily because of an overestimate, in my view, an overestimate of damages, but because how they add these all up. Now, there are two areas where I think the areas of what I call fundamental disagreement. One is the role of peer review in modeling and reducibility, and the other is on discounting. I'll deal with each of these. The first one a little briefly, and then the other one I'll spend most of my time on. Well, the review is a political document. It was presented here very eloquently by a distinguished scholar, but it's a political document, and advocacy is its purpose. But that is London, and this is Yale. And so I want to address it as a scientific study. One of the complaints I have about it is that if you go back, the central methodology by which science, and here I include economics as a science, operates is peer review and reducibility. But the study did not play by those ground rules. It was published without a prior appraisal of methods and assumptions by independent experts. I couldn't find a document with sources and methods that would allow me to reproduce the results. I couldn't retrack over their steps. Now, you might say, well, this is kind of academic politeness, but it's not. It's really fundamental to good science and economic analysis in London as in New Haven. These practices are ones that protect authors from mistakes, They help governments from digging themselves ever deeper into their own misguided realities. And the British government is not infallible in questions of economic and scientific analysis on global warming any more than it was on weapons of mass production 5 years ago. External review and reproducibility are essential for ensuring logical reasoning and appropriate respect for contrary points of view. And I very much wish that instead of publishing it, that it had gone through an internal review process and an external review process with an outside board of scientists and natural and social scientists before it was published. The main thing I want to talk about, however, today is the discounting controversy. And the second point here, and the main point I want to make, is that virtually the entire difference between the results in the review and those in most other studies lies in its approach to discounting. Now, at the outset, Nick Stern talked about that today, and he made very persuasive comments, I thought, about discounting. But I think we should I just want to start with a quote on a person I think is the leading economist on the analysis of discounting in economic growth, Chaling Koopmans. Chaling Koopmans was a Nobel Prize-winning economist at Yale when he did this work on discounting. And having spent many years studying it, and particularly studying the issues involved in low discounting, he wrote, "The problem of optimal economic growth is too complicated for one to feel comfortable making an entirely a priori choice of the time discount rate before one knows the implications of alternative choices." Now, this conclusion applies with even greater force in global warming models, which are much more complex than the models Koopmans analyzed. I think that the review simply got tangled up in the trees of high theory of discounting and lost sight of the forest. And if Gus Speth is here, he can tell them about the forest. Now, what are the practical implications here? The practical implications of the discounting centers on the appropriate real interest rate to use in making investments to slow climate change. And by a real interest rate, I mean the interest rate you use to compare goods and services over time. So goods in the 2100 versus goods today, or goods next year versus goods today. Not utilities and worthwhileness of generations in the future versus today. And I note in passing there are very complicated issues involved here that we could discuss, but we won't, concerning risk, uncertainty, the equity premium, the risk structure, taxes, borrowing constraints, and so on. So that's just for my scientific colleagues here who are going to complain what I'm saying is oversimplified. Now, the theoretical apparatus in the review leads to very low real interest rates. The equilibrium real interest rate in their view is 1.4% per year over the indefinite future. So when comparing potential, and this is on goods, when comparing potential investments in climate abatement on the one hand, with those, say, in education in America and China, vaccines in Europe or Africa, shelter anywhere, the Stern would discount the costs and benefits from climate investments at this very low rate. Now, my main concern is that this is a very simple one, that having gotten tangled up in the high theory of discounting from Koopmans on, it then basically seriously underestimated the return on investment. Now, maybe not in Merry England since 1914, but definitely it underestimated the rate of return in the United States, China, and much of the rest of the world. And I'll just provide one example from Jim Heckman, a Chicago Nobel Prize-winning econometrician and labor economist, has estimated the return on human capital, what else? Education. And he writes, quote, "The true rate of return to education in China may be as high as 30 or 40% per year." Now, I'm sure Jeff Sachs could find a similar large pool of high-yield investments in health and other infrastructure investments in Africa, and even the 20-year inflation index, super safe bonds in the United States, have a higher return than that used by the review. So let me just take a moment to examine what difference it makes. And if you go back and read Chris Hope's paper, his results are actually, mine are much simpler in structure than his, but his are very much the same. And he talked about this morning. So what I did just for this purpose, try to understand for myself what's going on, I drew upon an existing model of the economics of climate change known as the DICE model, which has been updated to recently available data, economics, and science. And then I made 3 runs, and those are described here. And if you want to look at the gory details, they're explained in a National Bureau of Economic Research working paper. And you can actually, if you want more the goriest of details, then you can go to my website. So there are 3 things I examined. One is what I call a kind of standard, plain vanilla, run-of-the-mill climate policy, where you ask, what does the optimal time path look like for the path of greenhouse gas abatement which maximizes this and that and the other thing over the indefinite future, using a higher time discounting rate of 1.5%, but one that is attempting to reproduce market interest rates. Then the second one was I just simply put in the Stern parameters, the discount rate that Nick talked about today, the pure time rate of 0.1%, and the elasticity of 1. That's run 2. And then run 3 was, okay, so I actually am not religious on this issue of what the time discount rate is, and I accept the point that it might be very low, it might be 0.1. I think 0's got some technical issues, but 0.1 is fine. And so, but I do insist that if you're going to do that, then you should have a model that actually tracks, you should have a set of parameters that track what's going on in the world, okay? You don't want to have oil prices at 10 cents a barrel. You want to have something that tracks market interest rates. So basically what I did was take the Stern assumption about the discount rate on time and recalibrate the utility function to get the market returns. So what do these show? Okay, well, I've got 2 graphs that give you an idea. Well, this is the first one, and I think this shows my major complaint with the Stern apparatus. They don't have really a model, but it's a model in the heads of the reviewers, and it was the Page model actually used it. So you can see here the top 2 lines are the models which are calibrated to track what I calculate as world real returns on capital. Just, I say 6 to 7%, but I'm not going to, I can't promise those are exactly the right numbers, but declining gradually over time as projected economic growth slows. If you look at the Stern numbers, the problem is that the existing estimate of the market return is way above the equilibrium. So what the model does is saves like mad. What the model tells you to do, saves like mad. Investment rates go way up, so you can get that interest rate down where it should be, which is near 1%. So what this says is that, to me, is that the Stern runs are basically inconsistent with the market returns on capital. Now, I can't stand here and say I know that my view is right and the Stern view is wrong. But they point to no evidence suggesting that their view on the return to capital is right. And I think there is substantial evidence, such as what I quoted from Heckman, that they are wrong. Now, the second slide shows a slightly different thing related to what we talked about this morning, which is the vision on the global carbon tax. So this is the social cost of carbon, which is one where the tax rate is set equal to the social rate, the social cost, so they're actually brought together. And what you can see is in the bottom show 3 runs. It showed the runs 1 and 3 that I mentioned earlier. It also shows another one, which is what the price has to be to limit carbon dioxide concentrations to 2 times original CO2, so the 550 path. And then the one almost off the screen there is the Stern run. That's to say the one, what you should do with the carbon tax if you really believe the 0.1 time preference and the 1% and the 1% elasticity of 1. And the point is that it's basically asking for much higher carbon taxes and much higher emissions reductions than are consistent with market interest rates. So for those of you who don't really know this unit of measure too well, just to give you some idea of the differences between the runs for US, if you take emissions and carbon tax and multiply those together, you get the total US carbon tax revenues or costs or transfers or distribution, around $30 billion for the mainstream view of in the $20 a ton and in the $300 billion per year, this is, for the Stern carbon tax. You get an increase in energy expenditures, that's your electricity, gasoline, and so on, bill of about 3% for the mainstream models and a little around 30% for the Stern. And you have an increase in average household energy expenditures in the U.S. households of a little over 200 for the mainstream and 2,500 for the Stern parameters. Now, I want to be clear here about this. The main point is that these are very large numbers. We have to respect the world we live in and the politics we live in. And I think actually what happens is if I were on the Stern team and looked at the implications of my ethical parameters, what I'd do is try to nudge those down a little bit to fit into reality. So let me conclude. How much and how fast should the globe reduce its greenhouse gas emissions? The Stern review answered these questions clearly and unambiguously. We need urgent, sharp, and immediate reductions. My conclusion is that the economic reasoning justifies this over the longer run, but not in the short run, that the economic policy recommendations in terms of immediate reductions are ones that are based on an unrealistic view of discount rates. So as I was thinking about a way to summarize this, I sent Nick an email where I said, I think it's a great study, but you're 50 years ahead of your time, in the sense that your carbon tax is 50 years ahead of where it ought to be. Well, okay, so then I was thinking, since everybody else is 50 years behind the time, if you average the two, you might come out just right. Thank you very much.